Geometry is all about studying and taking measurements of space. Since we live in a physical world, it is useful to mathematics to find physical quantities. We will start by defining a fundamental quantity called the angle. An angle is a measurement between two sides. So we have a side here, another side there. The angle is the measurement between these two sides, the like openness between the two sides. Angles are correctly measured in radians, but we normally use degrees in everyday language. Degrees, so the degree symbol is just a circle. So like this angle looks to be about 80 degrees. It's not that equal to radians. The radians is a measurement using pi, but we're not talking about that in this video. Degrees can be further subdivided into minutes and seconds. That was like an old, I think, nautical use of it. It's really not terribly useful because we just use decimal points of degrees, and we've got calculators to do that, so we don't really need to use minutes and seconds, but sometimes you'll see that coming up. Angles that are less than 90 degrees are acute angles. So an acute angle will look like something like this. Or of course, it can be in any direction. These are both acute angles. When you hit 90 degrees, this is called a right angle. Typically, we designate a right angle with a box because squares always have right angles. No matter how it's fashioned, as long as it's a right angle, it's you put that box no matter how it's located. Angles that are greater than 90 degrees but are less than 180 degrees are called obtuse. So this would be an obtuse angle. I'm just drawing this this circular thing here to show you what angle I'm talking about. You don't have to draw that, right? I could draw an obtuse angle like that, but just to make it clarify what angle I'm talking about this angle here. I could be talking about this angle, but typically we don't look at the angle that's the bigger one. In practice, we look at the smallest angle. That's the reason why. Well, you'll see in a little bit here. The last angle we talk about is a straight angle, and that's where two lines meet directly on a as a line. This is called a straight angle because it's a straight line. You just draw a line, and any point on this line, you can just find a point, and that's a straight angle. Right? You could keep going, you could find another point on the line, that's also a straight angle, and so on and so forth. As I said before, we don't look at anything greater than straight angles. That's because if we had an angle that's greater than a straight angle, something like this, right? This is definitely greater than 180. We actually don't consider that angle, we consider the smaller angle. And so this would be an obtuse angle. I'll also make a note that if two lines meet at a right angle, let me draw a better square. These two lines are called perpendicular. This is a very important theme in mathematics. It's actually, in general, it's called like orthogonality. But this perpendicular is what designates coordinate systems that we use in just many ways in analytic geometry. But this perpendicular property is very important to be able to make a reliable system. If we have two angles that are going to be, they kind of have to be acute. If we have two acute angles that add up to 90 degrees, we call them complementary. Complementary. You can see these two angles combined gives us a right angle here. That's called, these two angles then are called complementary, angle 1 and angle 2. If two angles, we'll name them angle 3 and angle 4, if two angles, angle 3 and angle 4 here, I drew that bad. If these add up to 180 degrees, these are called supplementary. E, not an I. Supplementary. And you can see that these two things combine together to just give us this 180 degree angle. Typically that can be made with an obtuse and an acute angle. It could also be made up of two right angles. Right? If both of these right angles are 90 degrees, then those are also supplementary. To keep that in mind, C comes before S and 90 comes before 180. So complementary is 90 degree angles that add up, it's two angles that add up to a 90 degree angle. Supplementary is two angles that add up to 180 degrees. Okay, here we have 6 angles, and we're just going to name them acute, right, obtuse, or straight. I would take a minute to see this on your own, and I'll go through the answers right here. So the first one, A, we can always kind of reference this with a 90 degree angle. Right, this is a 90 degree angle here. Angle A is definitely smaller than 90 degrees. So this is going to be acute. For angle B, we can draw it straight up. I should also make mention here, there's two ways of naming an angle. We could say this is actually angle, I was saying angle A because it's the 8th. That's really incorrect. I should say this is angle X. Sometimes they use angle with that symbol in there. X. This can also be written as angle ABC, and also be written as angle CBA. You may notice that B is always in the center. That's because B here is a special point. That's where the angle is really around. This point is called the vertex. The vertex needs to always be in the center of these angles. Because there's only one angle in problem A here, we can also call this angle angle B. That's because I can use all of these names. These are typically what you see: angle ABC, angle CBA. Typically, you'd see angle ABC since that's in alphabetical order, because those do not have any ambiguity to them. Angle X also has no ambiguity to it. You can see directly that the X is right there. That has to be the angle we're talking about. This one can have some ambiguity to it. Namely, if I had two angles coming off of it, and I said this was B, like A, C, D. If I said angle B here, you wouldn't know if I'm talking about this angle, or this entire angle. So you would never see angle B written in that context. Really, context always determines. It's a big thing in mathematics that context is what you got to use to tell you, where you're at. I like to use as descriptive of a thing as possible, so like this. But I would actually, in this case, use this since it's less to right, and it's clear exactly what I mean by angle X. So what you could say is just say that angle X is acute. Okay, for this one, we could say angle P0Q or POQ, angle QOP. You could also say angle O because there's no ambiguity there. And we can draw a right angle here. And you see that this angle is definitely bigger than 90 degrees, but it's smaller than 180. So we can say any one of these. I'm just going to use the top one. Angle POQ is obtuse. Greater than 90, but less than 180. For C, we have angle A here. That's the only name we can give it. Angle A. This is most definitely our right angle. Okay, this one's going to be named angle T. Angle T, this is definitely smaller than 90, right? You can draw a 90 there, which is acute. All right, this one's a little weird, but if you were to draw like a protractor and measure it, you can see that this is actually a right angle here. So this would be called angle 2. This is obtuse. It's greater than 90, but less than 180. And now here we have angle RST. Could be either this one or this one. And so it's a little confusing. It doesn't matter actually which one you do because both of them are going to be the same. Both of them are straight angles. Okay, in geometry, you will see the word congruent, and this is the same thing. It means kind of the same thing as equality, but congruency is more about shapes and figures. So two angles are congruent if they have the exact same measurement. So if I said that angle A and angle B are congruent, then if I said angle A equals 50 degrees, angle B equals what? Well, if angle A and angle B are congruent, that means they have the same measurement. And since angle A is 50 degrees, angle B must also be 50 degrees. Congruency doesn't matter location, right? Angle A looks to be like something like that. Angle B can look like this. Right, the location of it, how it's the orientation of it, all those things do not matter because congruency really is about the measurement of it, the physical properties of it being an angle measurement of 50 degrees. Now let's take a step back and talk about complementary and supplementary. Complementary, we said, was two angles add up to 90 degrees. So if angle E and angle F are complementary, and angle E equals 35 degrees, what does angle F equal? Complementary, right? C becomes before S, so complementary goes to 90 degrees because 90 comes before 180. So 35, or angle E plus angle F equals 90 degrees. In other words, 35 degrees plus angle F equals 90 degrees. This is just a one-step equation. All we have to do is get angle F by itself. That's our variable. We subtract 35 from both sides. And we get angle F equals 90 minus 35 is 55, I believe. Yep. So angle F is 55 degrees. Likewise, if I said that angle S and angle T are supplementary, and angle S equals 98 degrees, then we have that angle S plus angle T, which is the same thing as 98 degrees plus angle T, equals 180 degrees. Again, we have a one-step equation. We just subtract 98 from both sides. We get angle T equals 180 minus 98. That is, I believe, 82. Let me check that real quick. I think that's right, though. Yep. Angle T is 82 degrees. When two lines cross, the point at which they cross cuts the space up into 4 angles. For instance, I have one line here and one line here. You see here we have 1, 2, 3, and 4 angles. These are called vertical angles. Opposite vertical angles are equal. This isn't hard to show. All you have to do is consider each one of these things like kind of separately. So let's look at angle 1 and angle 4. Imagine this is the exact same line, and that we have something like this, right? Angle 1 and angle 4. These two angles are supplementary. Now, if we continue this line, angle 1 and angle 2, these are also supplementary angles. But angle 1 hasn't changed its measurement. So if angle 1 plus angle 4 equals 180, and angle 1 plus angle 2 equals 180, the only way for these two equations to be true is if angle 4 and angle 2 are the same measurement. And you can use that reasoning for all of the angles, and you'll see that angle 1 and angle 3 are congruent, and angle 4, or I should say angle 2 and angle 4 are congruent as well. So let's look at these vertical angles. We're not doing this one. That's not a vertical angle, but the rest of them are. For part A, we're just trying to figure out what's the rest of the angles, A, B, and C. Now we know opposite sides of vertical angles are congruent, so angle B must also be 125 degrees. We also know that angle A and 125 degrees, these are straight angles. They meet on a straight line. So we have angle A plus 125 must equal 180. So to find angle A, all we have to do is subtract 125. We get angle A equal to 55. Yes. So angle A equals 55 degrees, and therefore angle C must also equal 55 degrees. So that's all the angles there. Part B, angle E we know is 16 degrees automatically. Angle D is going to be 16 degrees plus angle D equals 180. Minus 16 from both sides. We get angle D equal to 170, 164, and therefore angle F is also 164. Angle C here, these two are straight angles. So we know angle P plus 70 degrees equals 180. Just subtract 70, and we get angle P equal to 110 degrees. E, this looks a little weird, but these are still vertical angles. So we know S is going to be equal to 60. And T, right, this is going to be a straight angle right there. So we just got to do angle T plus 60 equals 180. Subtract 60, we get angle T equal to 120 degrees for that one. Now F, these are not vertical angles. Actually P and Q are. You can see that this, let me do it in red here. This line here and this line here, these are vertical angles. So we can use that information because we know that P, angle P, is going to equal angle Q because they're vertical angles. We also know that this angle and this angle are equal because they're also vertical angles. Now, what makes up this angle? This angle makes up W plus 60 degrees. That's what that angle is. And that's going to be equal to 150 degrees. So all we have to do is subtract 60, and you see, oh, W is 90 degrees, which means it is a right angle. So let me get rid of the red here, write that in. We know that W equals 90 degrees. Now all I have to do is figure out what P and Q are. Now they're both the same thing, so we can use that information to help us out. We also know that this right here is a straight angle. 150 plus Q equals 180. Well, you can subtract 150 both sides. The only way that would work is if Q equals 30 degrees, right? 30 plus 150 is 180. So Q is 30 degrees and P is 30 degrees. And that kind of reasoning is what we do a lot in mathematics, is we reason out information from what we already know. That's how we can do proofs. And actually what I was showing you there was proofs by using different properties of angles, being complementary, supplementary, straight, vertical angles, those types of things. Suppose we have two parallel lines. These are lines that never cross. They go on indefinitely and they'll never cross each other. Now, if you take a third line and cross over both of these lines, this line is called a transversal. This thing creates two sets of vertical angles. We have, right there, these two angles are equal. These two angles are equal because they're vertical angles. We also have these two angles are equal. And these two angles are equal because they're vertical angles again. There are several properties about this transversal case here that we can use. And it all kind of comes back to the idea that the parallel lines are pretty much the exact same line, just moved down in space. And that we have two sets of vertical angles. What we know about this is that alternate interior angles are congruent. So I could say alternate on the interior, the inside being on the inside of the parallel lines. I say angle 1 here. Let's say angle A. These are congruent. They're the same measurement. If angle 1 is 30 degrees, angle A is also 30 degrees. The other pair of interior angles is angle 2 and angle B. I don't need to write the angle symbol there. Angle 2 and angle B are also congruent. This comes from the fact that they're vertical angles and they're just moved about in space. Angle 3 is congruent to angle C. That's because they are alternate exterior angles, exterior being on the outside of the parallel lines. And alternate exterior angles are also congruent. So angle 3 and angle C are congruent. Angle 4 and angle D are congruent. So angle 1 is congruency is actually designated as an equal sign with a tilde above it. Angle 1 and angle A are congruent. Angle 2 is congruent to angle B. Angle 3, let's see, where am I at? Angle 3 is congruent to angle C. And angle 4 is congruent to angle D. Now, there's even more that we can know, and that's because each one of these, let me do a different color here. Each one of these points here creates vertical angles. And we know opposite sides of vertical angles are congruent. Namely, angle A is congruent with angle D. Angle C, let me get rid of the red here. Angle C is congruent with angle B. That's because they're on opposite sides of the same transversal. Sorry, of the same vertical angles. We also know then, the same thing with the other set of vertical angles. Angle 1 is congruent to angle 4. Angle 2 is congruent to angle 3. And because angle 1 is congruent to angle 4, let me just show you here. Angle A is congruent to angle D. Angle 1 is congruent to angle 4. We have angle 4 is congruent to angle D. Angle 1 is congruent to angle A. We pretty much have every single case except for angle 1 is congruent to angle D. Angle where am I at? Angle A is congruent to angle 4. So we've just proven by using all of these properties together that angle D and angle 1 are congruent, angle 4 and angle A are congruent. So what you can do is you'll see that using all these congruencies, congruent, 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 I shouldn't use blue, I should use a different color, purple. Congruent, 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 and congruent. All the reds are congruent to each other, and all the purples are congruent to each other. This stuff is typically easier to see in practice, so let's just look at this. All of these are transversal angles. We can see that because these lines are perpendicular to each other. This line and this line is perpendicular, and so is this line and this line. And we have a transversal crossing them. So we have all the properties that we just discussed. Let's look at this. Vertical angles, opposite sides are congruent, so we know x is going to equal 100 degrees. That's because x and 100 are vertical angles. We also know that as long as they're on the same sides of all the vertical angles, they're going to be congruent. We have alternate exterior angles are also congruent. Well, if z is 100, y is a vertical angle to z, which means y is also 100 degrees. And last but not least, w is actually on the opposite side. It creates a straight angle with 100, which means 100 plus w equals 180. We just subtract 100 from both sides and we get w equals 80. We have 80 degrees. And now we know the rest of the angles. If we wanted to know them, they're all going to be 80 degrees. All right, part B. 60 degrees is that angle. We know G must also be 60 degrees. Alternating interior and exterior angles are congruent, so B must be 60 degrees, and A is also 60 degrees. Those are both alternate sides of the transversals. Okay, now we need to know what's the other side. Well, B and C here are straight angles. So we have 60 plus plus angle C equals 180. Subtract 60 from both sides, we get angle C equal to 120, which means F is 120, which means E is 120, and D is 120. Again, properties of vertical angles and alternate exterior, alternate interior angles being congruent. That's how I know all these things. The same thing is true for C, right? Q is 80 degrees. Alternate exterior angles, so Q and H are congruent. And we could know this angle here. It's not given to us, so it's not expected for us to find it. But we know that that angle is 80 degrees as well because it's alternate interior angles. All right, now we just need to figure out what the other side is. Again, we can just choose any one of these things. These are straight angles here, N and Q. So we have N plus 80, which is Q, equals 180. Subtract 80 from both sides, and you see we get 100 for N, which means M being a vertical angle to N is the same. Alternate interior angles is the same, and alternate exterior angles is the same. 40 here. I'm just doing this. It doesn't matter which order you do this in. I'm doing whatever is like I notice first. So like for part D here, I noticed first that 40 and X, these are alternate exterior angles. So I'm writing that immediately. But if you notice first that 40 and S are vertical angles, that works fine too. S and U are alternate interior angles. They're on the same side. They're on the inside of the parallel lines, but they're on the opposite sides of the transversal. So that's going to be also 40 degrees. And we can use any one of these things to find the other sets of angles. We just need to take straight angle, right? We get z plus 40 equals 180. I keep saying straight angle. These are also supplementary angles. It's the same idea. So z equals 120. Sorry, 140. So we know z is 140, which means y is 140, which means t is 140, and w is 140. Hopefully all of you know what a triangle is, but just for completion's sake, a triangle is a three-sided figure. The three sides all meet up with each other, and so each side meets together at a vertex, and therefore we have three angles. So it's a triangle, right? Now, triangles have this one of the most important properties in that every single triangle, if you add up all of the three angles inside of it, equals 180 degrees. So A, B, and C, actually, typically angles are used as capital letters. That's just a thing in mathematics. We have angle A plus angle B plus angle C. We should really say the measure of these, but I haven't been doing that. It's fine. Equals 180 degrees. That's a property they all have, so keep that in mind. All right, here we've got a few triangles. Part A says we have 60 and 52. Angle B is 60, angle C is 52. So angle A plus 60 plus 52 equals 180. All I'm going to do is subtract 60 and subtract 52 from 180 to find what angle A is. So 180 minus 60 minus 52 gives me 68. The next one is 23 and 20. So angle E is what we're trying to find here. We're trying to find this angle, right? So all we need to do is subtract 180 from 180, 23 and 20. That gives me 137 degrees. All right, C here, this is actually called a right triangle. That's because it has a right angle within it. Angle H is right, angle K is 48. Again, we're just trying to figure out what angle C is. We're just going to take 180 minus 90 minus 48 and see what we get. It gives us 42 degrees. All right, here we're trying to find that angle. Once again, 180 minus 27 minus 20. That gives me 133. This triangle is a special one. It's called an isosceles triangle. That's because these two sides are the same, and because these two angles are the same. Those two properties are equivalent. Two sides being equal is the same thing as two angles being equal for a triangle. Now, we don't know what two of the angles are, and we need to know what two angles are to find the third angle. However, we do know that both the angles A and A are equal to each other, which means I can write it like this: 40 plus A equals 180. That's just the same property we've been using. However, A and A are like terms, so they can combine and add. A plus A is 2A. And now this is a two-step equation. Subtract 40. 2A equals 140. And divide by 2. A equals 70. So both of these equal 70. You can check your work. 70 plus 70 is 140. Plus 40 is 180. I'm just going to clean this up by removing this work here. All right, this one has 127, so we're going to subtract those from 180. 180 minus 100 minus 27. That gives me 53 degrees. Once again, we have a right angle because 90 degrees is a right side, or a right angle. So this is a right triangle. That's what I meant to say. 180 minus 90 minus 27. That gives me 63 degrees here. Okay, here we have minutes and seconds. Or sorry, this is just minutes here. The same thing with this one. Minutes is a measurement. It's so that you don't have to use decimals when you're using degrees, but decimals are just easier to work with nowadays. Back in the day, it used to be much harder. To kind of give you an idea of how to work with these numbers, really, all we're doing here is dividing, but because how many minutes are in an hour? There's 60 minutes in an hour. It's the same idea with degrees. So if you want to figure out how many degrees there are, you just take the minutes and divide it by 60. And that tells you that I have 0.7166 repeating. I'm just going to run it 2 decimal places, 0.72. This is going to be degrees. So 109 degrees and 43 minutes is the same thing as 109.72 degrees. Obviously, the decimal is going to be easier to work with here because the minutes and seconds add more fractions and everything like that. So I'm just going to convert these into purely degrees. So 25 degrees and 32 minutes. 32 minutes is the same thing as 32 over 60. Gives me 0.533333. I'm just going to round to 2 decimal places. I'm just using the it's around this. This is like an estimation mark. It's not equal to that, but it is around there. So that means that 25 and 32 minutes is going to be the same thing as 25.53. Just like this is 109.72. So to find the third angle here, we just take 180 minus 109.72 minus 25.53. That gives me 44.75 degrees. Okay, same thing for this last one. I'm going to say 12 over 60 equals what? That should be 1/5, I believe. Yep, so 0.2. And then 46 over 60. That gives me 0. I'm going to round this to, this is going to be approximately equal to 77. So this angle is 73.77 and 46.2. So the third angle here is going to be 180 minus 46.2 minus 73.77. That gives me 60.03 degrees.